I am Sivakumar, Assistant Professor of Mathematics. I am having 20 years of professional experience in engineering colleges. Welcome to the channel Siva Discourse. Today we are going to discuss calculus. Already we have discussed a few topics in calculus in previous videos. In the first lecture video, I have discussed what is mathematics and what is the limit and continuity of functions of single variable. In the second lecture, we have discussed what is the relation between continuity and a differentiability. Now, in this lecture, we are going to see what is meant by a differential calculus and what is integral calculus. So, before going to see differential calculus and integral calculus, I would like to refer few professors. So, Gilbert Strang, from MIT. So, almost 63 years of professional experience in MIT, and Eugene Kotoriansky, he is an electrical engineer. He is famous for the animations. All these calculus topics he has done by means of animations. So, I would like to suggest to see these videos also to understand complete picture and big picture of calculus. Calculus is a mathematical study of change, and calculus means that is a relation between one function to another function. So here I am writing f of t, which stands first function, and s of t, which is a second function. Let us suppose that distance as the first function and speed is going to be the second function. And if you consider here some height of a person, height of a graph, and here we can consider slope of the curve, the second function. So many examples we could discuss. So here we have discussed two examples, and third one, if you consider money in the bank, then savings or spendings, we can consider as a second function. So if we are starting with this function and if we are going to find this function, that is nothing but differential calculus. From this function to this function, if we are going, that is a differential calculus. If they have given this function, second function, and we try to find out this function, that is called integral calculus. Before going to see these three examples, I would like to discuss what is the importance of what is meant by differentiation and what is meant by integration. For example, if we want to find out the entire object properties, if a small object properties are given, then we have to go for integration. If entire object properties are given and we are trying to find out small object properties, then we have to go for differentiation. Here I have to discuss what is the difference between algebra and calculus, where algebra is going to fail, where we have to depend on calculus. These things also I would like to discuss in this video. If you like the video, share the video to your friends and tap on the bell icon for getting more updates and for the upcoming videos. Now, we see all the three examples. That is, if we consider the first function here, time and f of t on y-axis, and if we consider a second function here, so this is also time, and here we consider s of t. In the first example, I referred This is we are considering the function f of t, we are considering a distance. Distance traveled in time t. And s of t we have considered as a speed. Speed at an instant of time. For example, if we consider some car is going with a constant speed. Let us consider this is some 40 kilometers per hour. The speed is constant. Now, if you consider for first 1 hour, because for 1 hour it is going 40 kilometers. So it is let us consider this is 40 and this is 1 hour, and the car will go like this. And after another hour, 2 hours, it will reach 80 kilometers. So that is another point. 2 hours, 80 kilometers. So like that. If you observe here, for 1 hour, for every 1 hour, car may not start at 0. If you see, this is a trip meter. This is referred in a trip meter. And the speed is referred in a speedometer. Generally, the trip meter is not going to be 0. If any vehicle is purchased newly, then it is going to be 0, or it is modified, then only it is going to be 0. So we may have this line that may starts from 80, or that may starts from some other number. But so according to this speed, for every 1 hour it is going 40 kilometers. Like that we can consider the graph of the line. So for example, this is the 1 hour we have considered, and in this 1 hour it is going 40. This is 40 and this is 1 hour. So total one, if we consider 2 hours, and here we have total is 80. 80 by 2 we can consider, that is a 40 kilometers per hour speed. Or if you consider 40 by 1, like that. So anyhow, all are nothing but 40 kilometers per hour. If the speed is constant, here we are observing the distance is a linear curve. It's like a straight line. So here, to find out the speed, or if the speed is given to find out the distance, we can use algebra. Just writing speed is nothing but distance by time. So according to these notations, s of t we can write f of t by t. But here we have discussed for a small change in time, what is the change in distance. So we can refer the same thing with the notation like delta f by delta t. If this time is negligibly small, then s of t, the speed, this one is denoted like this: limit delta t tends to 0, delta f by delta t. In this case, in this example, because speed is constant and this line is linear, with the help of algebra, we can say whatever the question we can ask. So here we consider another example with the changing speed. For example, time if we take here, distance if we take here, f of t, and if we consider the speed curve here, time here, and s of t here. So first it is start up with some speed. The car started with some speed. and later on if you see the speed is decreasing here, means speed means if you just draw a tangent line for this curve, the tangent slope here, the tangent slope is if you draw the tangent here, the tangent will be like this, means parallel to x-axis, slope is going to be 0. So here this is a decreasing speed. At here we are having speed, but that is not infinity because it is having some slope, and after that after some time in the traffic some red light came, so car has stopped here. And if you try to draw speed curve here for this distance curve, starting at this point it is starting with some speed, and later on the speed is decreasing, means for any unit time if you take, this is the unit time I have considered, so this is the change in the distance. And if you take same unit time here, so let us consider unit time here, the change you can observe, the change is very less. Here the change, same unit time, here the change is more, which means that speed is decreasing. Or you can consider here tangent, if you consider angle, inclination angle is more, and if you consider tangent here is almost 0 because the car has stopped, I said. So if you are trying to draw the speed curve, then speed is decreasing, and it is decreasing rapidly here, and after that here it is going to be 0. At this point the speed is 0. And again if you just turn this curve like this, means the car is coming backwards. If we observe both graphs, this is a sin x graph and this is a cos x graph. It is decreasing, so after this point the speed is negative. So like that we can discuss examples from one function to another function. Now we discuss second example. If we consider on x-axis time or age, we can consider on y-axis height of some person. Now here if we consider x and s of x, slope, and it generally starts with some height from childhood to 10 years. People will grow like a linear graph, and from 10 to 12 years, so the growth may be very fast. Up to 20 years they may grow very tall, and after that also little bit increase in the height, and after some old age height may drop. If you consider, if you try to draw the graph slope of this curve, if you try to draw, so here the slope is linear, here the slope is linear, it will come like that, and here the growth is more, it goes like that, and rapidly it will change here at this section. The growth is rapid, and after that immediately it falls down, and when it is a constant it's coming to 0, and after that we are having a negative slope like this. So from this graph you can draw this graph, from that graph you can draw this one. In the first example, we have considered constant speed, and from that graph we have drawn a linear curve. Now from this we are drawing this one. So this is about differential calculus and integral calculus. If one function is given and trying to find out another function, from first function to second function, if we are discussing, that is a differential calculus. We have to differentiate this to get this curve. And from second function to first function, we have to discuss integral calculus. So that's about differential calculus and integral calculus. Now I would like to discuss where we are going to use this calculus, where algebra will fail. So as in the first lecture I have discussed, mathematical study of quantity is number theory, mathematical study of structures is algebra, mathematical study of space is geometry, mathematical study of change is calculus. Now if there is no change, then we can simply solve the problem by using algebra. What is meant by algebra? Algebra means by means of symbols. If we are discussing some set of structures, then that is nothing but algebra. For example, simple example, we take a rectangle area. This rectangle is having 3 units length and 2 units breadth. 3 units length and 2 units breadth. Now area of this rectangle is given by 6 square units. Similarly, if we are taking another rectangle, let us consider this rectangle is having the area 4 units, 4 centimeters length and 3 centimeters breadth. Then the area of this rectangle is 12 centimeters square. And if you see, this is a rectangle and this is a rectangle. For each individual rectangle, no need to do the numerical calculation. If you are representing to find the area of all these kinds of structures, if you are representing a formula by means of symbols, we could write area is equal to length into breadth. That is nothing but algebra. So to find out area of all rectangles, we have a formula. To find out area of all circles, we have a formula. Means we are finding area, volume or whatever that property by means of a formula like symbols, which is known as algebra. So all these structures can be discussed with a simple formula. So that's why mathematical study of structures is called algebra. For example, if you consider a small spoke, otherwise you just consider this pen. Wherever you cut this pen, it is weighing 2 grams. Let us suppose that. Means the density of the material is constant, I am saying. Density means 3 types of densities exist. So 2 grams per centimeter I said. So this is the density, which is a linear density, I can say. Linear density. Let us suppose that this is of 15 centimeters length. Wherever you cut 1 centimeter is weighing 2 grams. So what is the total weight of this pen means 15 into 2, that is 30 grams. For that, calculus not required. We can simply solve that by using algebra formula. But if the density is keep on changing, from if you cut 1 centimeter here, it is the density is 2 grams, and after that it is weighing 4 grams. Like that it is changing, like some function that may be a discrete function or continuous function. Then definitely if you want to find out weight of this one, weight of this pen or mass of this pen, we have to find out that by means of integration. By using algebra, we are unable to solve the problem because there is a variation in the density. If there is a change, we have to go for calculus. As I have discussed this example, rectangle example, let us consider x-axis here and y-axis here. And I am drawing a line here is a line parallel to x-axis. Let us suppose 3 units. So a line parallel to x-axis, we can write y equal to constant, y equal to 3. Now if we consider some line here, let us suppose that the line is a 5 units distance, x equal to 5, and this line is y equal to 3. This line is x equal to 5. Now we can write this area by using algebra. No need to introduce calculus to find the area, because there is no change in the borders here. You can comfortably, by taking a simple square centimeter, we can able to refer this area. Area is given by 5 into 3, that is 15 square centimeters. But if it is not a constant function, it's not a constant line, this height is keep on changing like this, then if you find out this area, so what I am trying to say here is, x-axis if you take, y-axis is like this. Now I am not drawing the constant line, I am drawing a function like this. Now if I want to find out area beneath this curve between y-axis x equal to 0 and some line x equal to 5. Now if I want to find out this one, definitely I need calculus. I have to go for integration. We have to consider a small dx length, and that we have to multiply with this function length f of x dx, and that we have to integrate between y-axis means x equal to 0 to x equal to 5. So this f of x is nothing but this curve. Functions of single variable represents a plane curve, we know that. Now this will give the area beneath this curve bounded by these two lines, x equal to 0 and x equal to 5 and x-axis. So here we have to consider some integral. If we consider a to b f of x dx, and a single integral represents what? That depends upon what is the input we are giving for that integral. This one I am considering like a input. I am not concentrating on the integrand. This f of x is called integrand. I am just trying to say what is the input we are giving. For example, input if we are giving mass per length, linear density, as I said just before, in this case, the pen is made up of with a variable density. Then dx means another length, length will be gets cancelled. So we are giving a mass as input, we will get mass. For example, if you consider f of x is a curve like this, so we are giving input as a area, f of x dx means this is f of x length, and dx multiplying with this is area we are giving as input, so you are going to get area. We need complete information what we are giving as input for the integral, same will be getting in the output, but it will be enhanced. Differentiation means if we know entire object properties, we have to find out small object properties. For example, I have traveled almost 500 kilometers in 5 hours. What is my speed? 100 kilometers per hour. I mean, per 1 hour, what is speed? That is we are saying. The incomplete information I have given. That is 500 kilometers I have traveled in 5 hours. Complete information, entire information I have given. I am asking only in 1 hour what is happening. In 1 hour what is the distance I have traveled. Means a small object properties. From entire object properties, small object properties, we have to go for differentiation. If I know the speed, I mean second function, and if you are trying to find out first function, that is integral calculus. This is about differential calculus and integral calculus.